All right, so the video of example A has the first slide as all of the directions on your graphing calculator to find the maximum area. That is one option. The video option that I'm going to show you guys today is how to use Desmos. So Desmos is also another good option. Now that you guys are at home, you have access hopefully to a computer. If you don't, then you can stick with your graphing calculator. Just follow the instructions on screen. Also something good to know to find the maximum of a curve on your graphing calculator if you're taking AP Calculus next year. Just for the AP exam, you're not going to have Desmos, but Desmos is a good option. So I'm going to do the graphs for examples A and B on Desmos here. So you just go to desmos.com, start graphing, and then our first area equation for example A, we have the area in terms of x. Now, you guys have some options here. You could also type in y is equal to, and then type in that equation. You'll get the same curve, but I like to keep it uniform with what we've got. So the area in terms of x, for that example A, it was 4x, and then we had times the square root. Now, in Desmos, if you guys don't know what like the keys are or the codes are to get square root, you can just go down the bottom left, show the keypad, and you can get the square root button that way as well. Now, we had a fraction in the square root in example A. So before I type in minus 9x squared, I'm just going to hit the divide button so I can get a fraction. And then I'll go back up to the top and finish out that piece. Another option, again, you could say y is equal to 4x times the square root. And if you don't know how to get the fraction, we can just use parentheses minus 30 times 36, minus 9x squared. And then just divide that quantity by 4. You get the fraction that way as well. So it really doesn't matter. You get the same curve over here, but I can delete this equation so we can take a look at what we got. Now, this was the sketch that I had. It just looks a little bit different because I've got the scales different on the computer screen. But Desmos is really nice. You just go to the top where the maximum would be. There's our point. That's the point that we got in the video. So one other option besides using a graphing calculator, I think it's actually just a tiny bit quicker. So feel free to use that now on your homework in order to get those values. We didn't care about the negative parts down here because we were using this curve to represent area and half of the base. We're not going to take any of those lengths as negative values, so we're just focusing really on this area of the curve. The other equation we had from example B, the area of that triangle in terms of x, which is x times 16 minus x squared. That was, the parentheses do something weird here, this bigger curve here, and as you can see, if I go up to the top, hit that maximum point, 24.63 units, that was the maximum that we found in that example as well. Okay, before you guys get working on your homework, I do have some hints for the homework for maximization. So take a look if you'd like, but I think these might be helpful for drawing diagrams for the homework. Okay, so before I get into the diagram here, number 1 is just like example B. So kind of mirror number 1 after the second example video. Number 2 is just like example 1. So mirror number 2 just like example A, the video A. And then 3 you'll do. 4 is the trickiest one. So here's what I've done. I have made a diagram that represents 4. So if you guys look at the homework problem, a triangle is inscribed in the circle x squared plus y squared is equal to 25. That's just a circle of radius 5. And it has a vertex at negative 5, 0. And its base is a vertical chord of the circle. So I've actually done this in Desmos. If you guys look over at the left-hand side, this is actually what it took for me to get this diagram. So I wouldn't recommend trying to make it on your own. But essentially, this is what we've got. We've got our circle with a radius of 5 here. And I've got a triangle that's inscribed inside of this circle, and this is what it means with the chord. So the vertex is over here, that's that negative 5, 0 point. The chord of the circle, 2 points that connect the circle, that's the base of this triangle. Now remember, these diagrams are all about all of the possibilities here. So if we watch the slider here, we can change where the base of that triangle is drawn. So as the height of the triangle changes, we get varying triangle possibilities. So this is what happens, is we've got an infinite number of triangles that we can stick inside of this circle. And when we find the area equation, that equation will represent every single area possible by every single one of these triangles, depending on whatever value we write the equation in terms of. So I'm going to leave it like this for a minute, and I'm going to kind of mark this up to give you guys kind of a good place to start for your homework. Okay, so what do we know? Well, I know this. Let's do this in red. This distance from that vertex to the origin is 5 units long. We also are going to label this point in the upper right-hand corner xy. So then I know that this distance from the origin to wherever that base ends is x. So the total height of the triangle is 5 plus x. Okay, now if we think about it, this is going to work for every case. Here's why. I'm going to move the base of this triangle again. If I go into the slider, I'm going to move the base so that it's over here. We just said the height can be represented as 5 plus x. Now, in this case, this whole distance is 5. This whole distance is x, but x is actually a negative number this time. X is -1 maybe, right? Something close to that. So 5 plus x still remains true. It just becomes negative. The value of x becomes negative, and it becomes a subtraction problem. So please use 5 plus x as the height of that triangle. I will let you guys figure out what the value of the base is, but that's my hint for number 4.